statistics. Well, this data set was obtained by students during 3 laboratory classes. In the first column, we have the casein concentration. This is the percentage of protein that was determined in several whey protein samples. There was 5 whey protein samples. The codes of each whey protein samples were shown here. Uh, these whey protein samples were analyzed during 3 laboratory classes that were carried out during 3 different days. So we have the sample in this column, we have the laboratory class in this column, and we have the quantitative variable, the percentage of casein determined in each sample in this column. So we are going to load this data in JASP. We are going to here, open, and you select when your data set was. For example, I have saved my data set in this paste. This data set is also provided uh, as a Google Drive link. You're going to here. You select the spreadsheet and open. You must observe something. Uh, all my data set is in Microsoft Excel, but JASP just can read files in CVC format. So you can have your spreadsheet in Microsoft Excel format. You are going to File, Save As. You choose when you want to save your data set, and you select the CVC format. Now you can load your data in Microsoft Excel as a JASP file, so once that your data set was loaded, the first thing to do is descriptive statistics. First, we put in variable the quantitative variable, and we can separate your data set. For example, I have 89 measurements, and they have the mean, minimum, maximum of uh, protein percentage determined by students. I can separate by samples. Now I will split my results according to qualitative variable samples. So the data, the descriptive statistics is provided in here. You can go to this menu, statistics, and you can choose some other descriptive statistics. For example, median, interquartile range, variance, standard deviation, and you can also do the Shapiro-Wilk test. And here you can see if your data is normally distributed. I can say that a picture will show you then more than 1,000 words. For example, we can do distribution plots, display density plots. You can see how your data is distributed. And you can do box plots. So you might do box plots with your data set. My computer is thinking. Here we have the distribution plot. We have the distribution plots. In here you can see if your distribution, if your data is normally distributed. You can see that the data is normally distributed, but we have some asymmetric values. And in here, we have the box plots. Here we have the box plots. You can observe that when the data set is normally distributed, the trace that put the box is the median. So if the data is normally distributed, this line will be in the middle of the box. This line could be sometimes uh, top or down, but it don't mean that your data was not normally distributed. You can also, in Boxplots, select violin elements that you are going to see. This distribution you'll be see in the Boxplots quite in here. Why should the first thing that we do when we are looking for a data set is to do Boxplots? Why have to do box plots? Because box plots show outlier results. Outlier results uh, strongly influenciate your data. So the first thing that you must do when you are analyzing a data set is to do a box plot and delete outlier values. So these outlier values are going to be deleted. And then I will compare my data sets before outlier results exclusion. In the next video, I will show how to compare these results using one way or another.